Here's an example of an AC coupled PV plus storage system. It's pretty much the first two topologies that we went over connected to the same AC panel. In this, we have coupled both batteries and PV to the grid. They're entirely separate systems that can operate autonomously and independent of each other. Typically with these systems, the inverter or converter needs to follow anti-islanding that utilities require, meaning that the inverters cannot push power out locally, creating a live island of electricity when there is a grid outage. This prevents backfeeding of the grid and a smooth ramp up of power when the grid does recover. During an outage, backup power has traditionally not been available unless additional hardware and control systems are installed to safely isolate the site and prevent backfeeding. Here is what an AC coupled system could look like with additional hardware or controls to prevent islanding, but still provide power to the backed up loads. This has some type of relay or switch that opens up automatically when there is a power outage and keeps the PV and batteries connected to an added backed up panel to keep the desired loads powered up. However, these inverters traditionally need some AC source to act as a grid and serve as a voltage source for them to turn on. Now, a battery plus inverter system can act as that if it had the right hardware and logic, but we're getting ahead of ourselves. This is where these types of systems can get really complicated really fast. In the next video, we'll start diving into my favorite topic, DC coupled PV plus storage systems. See you there.